Hi students, welcome to this section of algebra where we deal with linear equations. Now there will be future sections where we deal with more advanced concepts of algebra, but right now let's get started with the basics. Now, what is an equation? An equation is a condition on a variable. Now, it's also good to note that the equation is only satisfied for a definite value of the variable. Now, let's try to understand what I mean with these two statements. Let's take an example. For example, you have an equation 2x is equal to 20. Now, what all can we observe over here? You can see that there is an equality sign and this is necessary for an equation, right? You need to have this for an equation. All right. Now, when is this equation true? This is true when x is equal to 10, right? When x is equal to 10, 2 into 10 is equal to 20. So that's what we say that it's true only for a definite value of the variable. All right, let's proceed and see how we can solve an equation. Now, an equation is like a balanced weighing balance. All right, so you have a left hand side and you have a right hand side of the equation. So over here we had 2x is equal to 20. So this is called the left hand side LHS, that is left hand side of the equation, and this is the RHS, that is the right hand side of the equation, and these two are balanced, right? So that's why we have this picturized as a balanced weighing balance. Now over here on the left hand side I have 2x and on the right hand side I have 20. All right, now whatever I do on the left hand side, I should do the same thing on the right hand side. So let me divide both sides by 2. So I have 2x by 2 over here and 20 by 2 over here. So 2x by 2 is equal to x and 20 by 2 is equal to 10. So I get x is equal to 10. So that's how we solve equations. Let's take another example. I have 3x minus 15 is equal to 20. So this is the left hand side and this is the right hand side. Now let me add 15 to both the sides. So I get 3x minus 15 plus 15 is equal to 20 plus 15. All right. So over here I have minus 15 and plus 15. These two cancel out. So my left hand side becomes 3x and my right hand side is 20 plus 15, that is 35. So 3x is equal to 35. Now let me divide both the sides by 3. So I have 3x by 3 on the left hand side and 35 by 3 on the right hand side. So 3x by 3 is nothing but x, right? These two get cancelled out. So I get x is equal to 35 by 3 and that is the solution. All right. Now we have seen that an equation is like a balanced weighing balance, and whatever you do on the left hand side, you have to do the same thing on the right hand side. Let's see one more way of thinking of this. Now, the other way is called transposing a number. So that means when you take a number from the left hand side to the right hand side, what happens? Let's try to observe. So I take the same equation. I have 3x minus 15 is equal to 20. Now let me take this minus 15 to the right hand side of the equation. So what happens is what is negative on the left hand side should become positive when you take it to the right hand side. So this becomes 3x is equal to 20 plus 15, and that is 3x is equal to 35, and then we divide both the sides by 3, or I take this into 3 to the right hand side. So if you have into over here, when you take it to the right hand side, it becomes divided by. So x is equal to 35 divided by 3, which is the same thing that we got over here. So let's quickly summarize transposing a number. If you have an addition on the left hand side, when you take it to the right hand side, it becomes subtraction. Similarly, if you have a multiplication on the left hand side, we had over here 3x, right? That is 3 into x. When you take it to the right hand side, it becomes division. So that's why we have over here 35 by 3. And you can see that it's one and the same. These two are one and the same, right? It's just different ways of thinking about the same thing. Now over here, if you had division, when you take it to the right hand side, it becomes multiplication. So if I have an equation x by 3 is equal to say 10. If I want to take this 3 to the right hand side, over here it's division. So over here it becomes multiplication. And I can say x is equal to 10 into 3, right? Now if I have subtraction on the left hand side, on the right hand side, it will become addition. Hi students, in a previous video, we had seen how to add or subtract fractions. Now let's see how to handle fractions when it comes to equations. The same principle applies. Let's take an example to understand it better. Now we have a sample question over here. Find a number such that half of the number is 5 more than 1/3 of the number. Now we start by assuming the number as a variable. So let the number be x. Alright. Now half of the number would be x by 2, and it's given that x by 2 is equal to 5 more than 1/3 of the number. 1/3 of the number would be x by 3. So x by 2 is equal to x by 3 plus 5. So we have converted this statement into an equation. Now we know the principles of solving an equation. Whatever we do on the left hand side, we should do the same thing on the right hand side, or we can also think of it in terms of transposing a number. Alright, now let me transpose x by 3 to the left hand side. So over here this is plus. So when I transpose it to the other side, it becomes negative, right? So this is x by 2 minus x by 3 is equal to 5. Now over here we have two fractions, and we have 2 in the denominator over here, and in the denominator over here we have 3. So the same principle that applies to adding or subtracting fractions applies over here also. We need to make the denominator the same, right? So let's take the LCM of 2 and 3. The LCM of 2 and 3 is equal to 6, right? So we need to convert this fraction into a fraction with the denominator 6, and the same thing has to be done over here as well. Alright, so we can write this as 3x by 6 minus 2x by 6 is equal to 5. How do we do that? Over here we have x by 2. Now let me multiply the numerator and denominator with 3. So that's equal to 3x by 6, right? So that's what we have over here. And this is x by 3. Let me do the same thing over here. I have x by 3. Let me multiply the numerator and denominator with 2. So I get this as 2x by 6. That's 2x by 6 over here. Now 3x by 6 minus 2x by 6 is equal to 5, right? Now the denominator is the same. So I just need to do the operation, which is subtraction in this case, to the numerator. So this is equal to 3x minus 2x by 6 is equal to 5, right? Now 3x minus 2x is nothing but x. So we get x by 6 is equal to 5. Now let me transpose this 6 to the right hand side. Now over here it's division. So when I take it to the right hand side, it will become multiplication, right? So we get x is equal to 5 into 6, which is equal to 30. And that is the solution to this equation. So remember, when you handle fractions in an equation, the same principles apply. We need to make the denominator the same to simplify the equation. Hi students, in this video, let's try to understand what we mean with distributivity and apply it in some equations. Alright, let's get started. Over here I have Divya, and over here I have Bob. Now both of them want to buy some notebooks. Now it's given that one notebook costs $10. Now Divya needs 3 notebooks and Bob needs 4 notebooks. Now we are asking them to find the total money that both of them together will spend. Now both of them approach this problem in a different manner. Divya first finds what is the money that she spends. That would be 3 into 10 because she is buying 3 notebooks. And what is the money that Bob spends? So that would be 4 into 10 because he is buying 4 notebooks. So Divya finds that the total money spent is 3 into 10 plus 4 into 10, which is equal to $70. Alright, now Bob first thinks of what is the total number of notebooks bought. So Bob calculates that as 3 plus 4. So a total of 7 notebooks are bought and each notebook costs $10. So Bob calculates it as 3 plus 4 into 10. So that's 7 into 10, which is also equal to $70. So both of them got the same answer, and by this we know that 3 into 10 plus 4 into 10 is also equal to 3 plus 4 into 10. Alright, so this is what we call distributivity. So over here I have a bracket, and by opening the bracket, what am I actually doing? I'm just distributing into 10 to both these numbers. So I have 3 into 10 over here and 4 into 10 over here, and in between, because I have a plus over here, I have a plus over here. Alright, let's keep this aside. Now let's try to apply this in the case of an equation. So over here I have 3 into x plus 6. So how do we expand this? It's the same principle as what we've used over here. you can see that here we gave into 10 both to 3 and 4. The same thing we do over here. Let's give into 3 to x. So we get 3x, and over here we have a plus sign. So over here also we need to have a plus sign, and then let's give into 3 to 6. So that's 3 into 6, right? So 3 into x plus 6 simplifies to 3x plus 3 into 6. That's equal to 3x plus 18. Alright, let's take one more example. What about 5 into 3 minus 2x? Let's give into 5 to 3. So that would be 5 into 3. And over here we have a negative sign. So over here also I need a negative sign. And let's give into 5 to 2x. So that would be 5 into 2x. So this simplifies to 5 into 3, that's 15, minus 10x, right? 5 into 2x is 10x. Alright, now let's apply this in a multiplication. Say you want to do 23 into 106. So I can write 23 as 20 plus 3, and I can write 106 as 100 plus 6. So when I multiply this, let's treat this part as 1 unit. Alright, so let's give this 1 unit both to 20 and 3. So we get 20, and we have 20 and 3 over here. So let's give this to 20 and let's give it to 3. So we have 20 into 100 plus 6 and 3 into 100 plus 6, right? And over here I have a plus sign. So over here also I need to have a plus sign. Alright, now let's open this bracket. So I get 20 into 100 plus 20 into 6, right? Over here there is a plus, that's why there is a plus over here. Plus, which is this plus, right? 3 into 100 plus 3 into 6. Over here there is a plus, that's why there is a plus over here. Now we get that this is equal to 2000 plus 120 plus 300 plus 18, which is equal to 2438. Alright, now let's proceed and apply this in the case of an equation. Alright, so let's say that you want to solve this equation 3x minus 5 by 2 is equal to x plus 1 by 3. Alright, now you can think of it in two ways. Let's think of it in terms of transposing the number. If I transpose 3 to this side, it becomes into 3, right? Similarly, if I transpose this 2 to the right hand side, it becomes into 2. That's the same as doing the cross multiplication, right? So we do into 3 over here and we do into 2 over here. So this becomes 3 into 3x minus 5 is equal to 2 into x plus 1, right? Now let's open this bracket. So this becomes 3 into 3x minus 3 into 5, right? So 3 into 3x minus 3 into 5 is equal to 2 into x. That's this part, plus we have a plus over here, 2 into 1. So that's this part. So this simplifies to 9x minus 15 is equal to 2x plus 2, or if you take 2x to the left hand side, it becomes minus 2x. So 9x minus 2x is equal to 7x, right? And if you take minus 15 to the right hand side, it will become plus 15. So 2 plus 15 is equal to 17. So we get 7x is equal to 17, or x is equal to 17 by 7, right? Over here that's into 7. If you take it to the right hand side, it will become divided by 7. So that's what we have done over here. And with this we have solved for x. All right. Now let's also think of it in this manner. I have 3x minus 5 by 2 is equal to x plus 1 by 3. All right. Now you can see that if I multiply this side with 2, I need to multiply this side with 2, right? So I get 3x minus 5 is equal to x plus 1 by 3 into 2. Now let me multiply both sides with 3. All right. So over here this 3 and this 3 cancel out. So I get 3x minus 5 into 3 is equal to x plus 1 into 2, which is the same thing that we had over here. So cross multiplying is the faster way and faster way of thinking of solving these type of equations. Alright, now let's practice solving a few equations. Now the first one over here is 7y plus 23 by 3 is equal to 12. Now let me take this 23 by 3 to the right hand side. So over here it's plus, so over here it will become minus. So I get 7y is equal to 12 minus 23 by 3. Alright, now 12 can be written as 36 by 3, right? How do you do that? 12 is nothing but 12 by 1. Now I need the denominator to be 3, right? So I multiply numerator and denominator with 3. So this is equal to 36 by 3. So this part over here becomes 36 minus 23 by 3, which is equal to 13 by 3. Alright, so we have 7y is equal to 13 by 3. Over here we have into 7. So let's take that to the right hand side. So that will become divided by 7. So y is equal to 1 by 7 into 13 by 3. That's equal to 13 by 21, which is the solution of this equation. Alright, let's do the second one. We have minus 4 is equal to 2 into x minus 7. Let's take this 2 to the left hand side. So over here it is into 2. So if you take it to the left hand side, it will become divided by 2. So you get minus 4 by 2 is equal to x minus 7. And minus 4 by 2 is nothing but minus 2. So minus 2 is equal to x minus 7. Let's take this minus 7 to the left hand side. So it will become plus 7. So x is equal to minus 2 plus 7, which is equal to 5. That's the solution to this equation. Alright, now let's solve one more equation. We have x minus 9 by 3 plus 2x by 5 is equal to 7 minus x by 2. Alright, now over here let's start with simplifying the left hand side. I have 3 over here and 5 over here in the denominators. So let's find the LCM. LCM of 3 and 5 is equal to 15. Now I need to change x minus 9 by 3 into a fraction which has 15 in the denominator. So how do I do that? I multiply the numerator and denominator with 5. Alright, so plus and 2x by 5 has to be changed to a fraction with 15 in the denominator. For that I multiply the numerator and denominator with 3. Alright, so this becomes x minus 9 by 3 into 5 by 5 plus 2x by 5 into 3 by 3. Alright, now what about the right hand side? Over here I have 7. That's the same as 7 by 1. I need to change this to a fraction with 2 in the denominator. So this is 2 into 7 by 2 minus x by 2. Alright, now over here the denominator is 15. Over here the denominator is 15 and over here the denominator is 2. Let's simplify this. We get 5x minus 45, right? By distributing this 5 to x and minus 9. So we have 5x minus 45 plus 6x. That's this over here. That's 6x by 15 is equal to 14 minus x by 2. Remember over here we had x minus 9 by 3 into 5 by 5, right? So when you multiply the numerator with 5, it's the same thing as having a bracket over here and multiplying with 5. Alright, let's proceed. Now 5x plus 6x is equal to 11x. So the numerator over here is 11x minus 45 by 15. That's the denominator. And that's equal to 14 minus x by 2. Let's make some space over here. Alright, so now we can proceed and cross multiply. Let's do that. So we get 2 into 11x minus 45 is equal to 15 into 14 minus x. Now let's simplify. Let's distribute this to these two parts. So we get 22x minus 90 is equal to 15 into 14. That's 210 minus, that's this minus over here, 15 into x, which is 15x. Alright, now let's take this minus 15x to the left hand side. It will become plus 15x. And let's take minus 90 to the right hand side. It will become plus 90. So we get 22x plus 15x. That is 37x is equal to 210 plus 90, which is 300. Now let's take this 37 to the right hand side. So over here it is multiplication. So on the right hand side it will become division. So x is equal to 300 by 37, which is the solution to this equation. Hi students, in this video let's discuss linear equations with more than one variable. Now if you have two variables, you will need two equations to solve and find the value of the variables. Now similarly, if you have three variables, you will need three equations to solve them. Alright, now let's understand both of these and how to proceed in these scenarios, taking examples. We start with the case where two variables are involved. Let me bring a sample question to your attention. An apartment has flats with 2 bedrooms and 3 bedrooms. Total number of flats is 100. Total number of bedrooms is 260. Find the number of 2-bedroom flats. Alright, now to solve this, let's take the number of 2-bedroom flats as x and the number of 3-bedroom flats as y. Alright, now it's given that the total number of flats is 100. So that means x plus y is equal to 100, right? Alright, now x flats have 2 bedrooms. So what's the total number of bedrooms from these x flats? that would be 2 into x, right? And y flats have 3 bedrooms each. So the total number of bedrooms among these y flats would be 3 into y. Now the total number of flats would be 2x plus 3y, and that is given as 260, right? So we have one more equation, 2x plus 3y is equal to 260. Now you can see that this equation has two variables and this equation has two variables. So we need two equations to solve and find the value of x and y. Alright, let's keep this aside. Alright, now for solving these two equations, let's observe the coefficients of the variables. So over here, x has a coefficient of 1, y has a coefficient of 1, and x has a coefficient of 2, and y has a coefficient of 3. Alright, now to solve this set of equations, make the coefficients of either x or y the same for both the equations. Alright, now let's number the equations. Let this be equation 1 and this is equation 2. Now over here I have x plus y is equal to 100. Now let's multiply this equation throughout with 2. We can do that, right? We have seen that a balanced equation is like a balance. Whatever you do on the left hand side, you have to do on the right hand side. So I have x plus y is equal to 100. Now I can multiply both the sides with 2. So I get 2 into x plus y is equal to 2 into 100, right? So that is 2x plus 2y is equal to 200. Alright, and the second equation is 2x plus 3y is equal to 260. Now let me subtract this minus this. So if this is equation A, this is equation B, what I am doing is A minus B. Alright, so over here that's 2x minus 2x which is equal to 0, and over here that's 2y minus 3y which is equal to minus y, and over here I have 200 minus 260 which is equal to minus 60. So I get minus y is equal to minus 60. Alright, so if minus y is equal to minus 60, y is equal to 60. Alright, now to find the value of x, let's substitute this in either of these equations. So let's do it over here. So we get x plus 60, right, is equal to 100, and let's take this 60 to the right hand side. So I get x is equal to 100 minus 60 which is equal to 40. So we have solved the equation. So you can see that over here if you substitute x is equal to 40 and y is equal to 60, you will get the sum as 100. The same applies over here. If you do 2x, that would be 2 into 40 which is 80 plus 3y, that's 3 into 60 which is 180. So 80 plus 180 is equal to 260. Therefore x is equal to 40 and y is equal to 60 satisfies both the equations, or x equal to 40 and y is equal to 60 is the solution of this set of equations. Now you can note that over here, because we had two variables, we needed two equations to solve. Alright, now let's proceed to the case where three variables are involved. Now if three variables are there, over here you have x, y and z, right? You need three equations to find the value of x, y and z. Now this could be the equation form of any type of word problem. For example, you are buying apples and you are buying oranges and you are buying watermelon. Now the cost of one apple is x dollars. The cost of one orange is y dollars, and the cost of one watermelon is z dollars. Now it may be given that if somebody is buying 3 apples, 2 oranges and 4 watermelon, they have to spend $19. If they are buying 4 apples and 1 orange and 7 watermelon, they have to spend $27. And if they are buying 1 apple, 3 oranges and 1 watermelon, they have to spend $10. And we have to find x, y and z. Alright, if that were the question, the first step would be to form these three equations, and then we need to solve these three equations to find x, y and z. Alright, let me make some space over here. So we have these three equations and each equation has three variables. Now we are trying to solve it. Now the first step is we need to eliminate one variable and solve, and then we need to substitute back. So we keep doing this. So basically first we have to eliminate one variable and then we have to eliminate one more variable. so that you are just left with one variable to solve. Let's see how to do this. Let's number these equations as 1, 2, 3. Alright, now equation 1 is 3x plus 2y plus 4z is equal to 19. Now let me take equation 3 and multiply throughout with 3. So I'm multiplying the left hand side and the right hand side with 3. So I get 3x plus 9y plus 3z is equal to 30. Alright, now let's do a minus b. If this is a, this is b. We are doing a minus b. So that gives you 3x minus 3x, which is equal to 0. So we have successfully eliminated x. Now over here we have 2y minus 9y, which is minus 7y, and 4z minus 3z is z is equal to 19 minus 30, which is equal to minus 11. Alright, let's proceed. Now over here I have equation 2, which is 4x plus y plus 7z is equal to 27. Now let me take equation 3 and multiply the left hand side and right hand side with 4. So I get 4x plus 12y plus 4z is equal to 40. Alright, now let's subtract a minus b. So over here 4x minus 4x. So we are eliminating this x, right? And then you have y minus 12y, which is minus 11y, and 7z minus 4z, which is 3z. That's equal to 27 minus 40, which is equal to minus 13. So let this be equation 4 and let this be equation 5. Now these two equations only have two variables, right? Now let's proceed and eliminate one more variable. Alright, so I write equation 5 over here and equation 4 multiplied with 3. If I multiply equation 4 with 3, that's 7 into 3, you get minus 21y, and 1 into 3, that's 3z, right? So minus 11 into 3 gives you minus 33. Alright, now if this is a and this is b, let's do a minus b. So over here you get minus 11 minus minus 21, that is equal to plus 10. And over here you can see that these two cancel out, right? So we get 10y is equal to minus 13 minus minus 33. That's the same as minus 13 plus 33, which is 20. So 10y is equal to 20, or y is equal to 2. So we have found the value of y. Now let's substitute it back, say to this place over here. You could do it over here or here. Now if you substitute it over here, you get minus 22 plus 3z is equal to minus 13, right? Let's take minus 22 to the right side. So it becomes plus 22. So 3z is equal to 22 minus 13, which is 9, or z is equal to 9 by 3, which is equal to 3. Alright, so we have found the value of z and y. Alright, now let's substitute these two into this equation over here. So we get 3x plus 4 plus 12 is equal to 19. So 4 plus 12 is 16. So on taking it to the right hand side, it becomes 19 minus 16, which is 3. So 3x is equal to 3, or x is equal to 1. So we have found the solution to the set of these three equations. X is equal to 1, y is equal to 2, and z is equal to 3. Let's do this question. There are cows and chicken in a farm. Bob counted 39 heads and 126 legs. How many cows are there in this farm? Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now let's take the number of cows as x and the number of chicken as y. Now cows have 4 legs and chicken have 2 legs. Now it's given that the heads counted were 39. So x plus y is equal to 39, right? Now the number of legs is 126. Therefore the total number of legs by the cows is 4x and the total number of legs by chicken is 2y, right? As the total number of legs is 126, 4x plus 2y is equal to 126. Alright, now let me write this equation over here. 4x plus 2y is 126. Now over here I have x plus y is equal to 39. Let's multiply it throughout with 2 and I get 2x plus 2y is equal to 78. Alright, now let me do a minus b. If this is equation a, this is equation b. A minus b will give me 4x minus 2x, that is 2x, and 2y minus 2y gets cancelled. So 2x is equal to 126 minus 78, which is 48. Therefore, let's take this x to the right hand side by dividing 48 by 2. X is equal to 48 by 2, which is equal to 24. And that is the number of cows because we have taken the number of cows as X, which is answer option C. Let's do this question. Anita is 3 times as old as her daughter. 2 years from now, she will be 4 times as old as her daughter. Find the present age of the daughter. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, let's do it together. Let the daughter's present age be X. Alright, now the mother's age would be 5X, right? Because it's given that Anita is 5 times as old as her daughter. So Anita is 5x years old. Alright, now 2 years later, the daughter will be X plus 2 years old, right? And Anita would be 5x plus 2 years old. Now it's given that at that time, Anita would be 4 times as old as her daughter. So that means 4 into the daughter's age would be Anita's age. So 4 into x plus 2 is equal to 5x plus 2. Now let's distribute into 4 to x and 2. So we get 4x plus 8 is equal to 5x plus 2, or on solving, let's take 4x to this side and 2 to this side. So we get x is equal to 6. That is the age of the daughter, because the present age of the daughter is x, and we have solved and found that x is equal to 6, which is the answer. Let's do this question. Felix is planning a trip. He plans to hire a tour guide. The tour guide charges a fixed cost per day, which he has to pay irrespective of the number of miles they travel. On top of that, he has to pay a variable cost per mile traveled. He found that if he plans a 3-day trip covering 200 miles, it will cost him $720. And if he plans a 4-day trip covering 300 miles, it will cost him $1,060. Find the fixed and variable cost. Alright, pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Now let's take the fixed cost as X and let the variable cost involved be Y. Alright, now if he is planning a 3-day trip and covering 200 miles, it's costing him $720. So let's form the equation. We can say that 3x plus 200y is equal to 720, right? This is the fixed cost, and because it's 3 days, that's 3 into x. So we have 3x over here, and they are covering 200 miles, and per mile he has to pay y dollars. So that's a total of 200 y dollars, and the sum of this is equal to 720. Alright, now if he is planning a 4-day trip and covering 300 miles, it costs him $1,060. So 4x plus 300y is equal to 1060. Alright, let this be equation 1 and this is equation 2. Now observe the coefficients. Alright, now remember we need to make the coefficient of x or y equal for both the equations to cancel it out. Now let's multiply equation 2 with 3 throughout. So 4 into 3 is 12, 300 into 3 is 900, and 1060 into 3 is 3180. So the equation becomes 12x plus 900y is equal to 3180. Now let's multiply equation 1 throughout with 4. Alright, so 4 into 3 is 12. So 12x plus 800y is equal to 2880. So you can see that over here we applied a technique. We saw we have 3 over here. So we multiplied equation 2 with 3. We saw we have 4 over here. So we multiplied equation 1 with 4. So in that case, the coefficient of x in equation 1 and 2 will become 12. So that's what we've got over here. Now let's subtract, and these two get cancelled out. 900 minus 800 is 100. So we get 100y is equal to 300, or y is equal to 300 by 100, which is equal to 3. Now to find x, let's substitute y over here. Alright, so we get 3x plus 200 into 3, that is 600, is equal to 720. Therefore 3x is equal to 120, or x is equal to 40. Therefore the correct answer to this question is 40 and $3, which is answer option A. Hi students, in this video let's discuss when a system of equations with two variables has no solution, unique solution, and infinite number of solutions. So that there are 3 cases over here. Alright, now we are only dealing with equations with 2 variables. for 3 variables, we would need a different concept called matrices to explain it, which is not required for this exam. So we stick to 2 variables to identify these 3 scenarios. All right, let's proceed. And over here, I have the first scenario. Let's first take an example and we see an example for all the 3 cases, and then we'll discuss the criteria. Now, if I have 2 equations that say x plus y is equal to 100 and 2x plus 2y is equal to 300, you can see that these 2 equations are inconsistent and hence they will have no solution. Now, what do I mean when I say that they are inconsistent? Over here, I have x plus y is equal to 100. Now, let me multiply it throughout with 2. So I get 2x plus 2y is equal to 200, right? But over here, it's mentioned that 2x plus 2y is equal to 300. So these two are not consistent. Therefore, there will be no solution for these 2 equations. All right. Now, you can see that if I have these 2 parts, if you subtract it, you will get 0 is equal to 100, and which is also not true, right? And that's because these 2 are not consistent. All right. Now, let's proceed to the second case. That is where you have a unique solution. We have 2 equations, x plus y is equal to 100 and 2x plus 3y is equal to 240. All right. Now, let me multiply this throughout with 2. So I get 2x plus 2y is equal to 200 and 2x plus 3y is equal to 240. Now, on subtracting, these 2 cancel out, and over here I have minus y is equal to minus 40, or y is equal to 40. Now, I can substitute that over here and I will get x is equal to 100 minus 40, which is 60. So you can see that there is a unique solution for this set of equations. All right. Let's proceed to the case where there are an infinite number of solutions. All right. Now let me have 2 equations, x plus y is equal to 100 and 2x plus 2y is equal to 200. Now these 2 equations will have infinite number of solutions. What are some examples? You could have 1 and 99, or 20 and 80, or 55 and 45, or 50 and 50. All of these are equations for these 2 equations. Now you can see that in fact, if you multiply this throughout with 2, you will get to this equation. So that's why these 2 have infinite number of solutions. All right. Now let's keep this aside and check a criteria with which to identify whether 2 equations that are given have no solution, a unique solution, or infinite number of solutions. All right. Now let me write a generic expression of 2 equations. So I have a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So you can see that I have used variables as the coefficients, right? Now let's analyze these 2 equations. If you have a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, in that case there will be no solution for this set of equations. Now over here also you can see that you have 1 by 2, 1 by 2 and 1 by 3, right? So it's the same thing that's happening over here. So it's 1 by 2, 1 by 2 and minus 100 by minus 300 if you're taking it to this side as per this part, right? So that would be minus 100 and minus 300. This is 1 by 2, this is 1 by 2 and this will be 1 by 3. So the criteria over here is a1 by a2 is equal to b1 by b2, but it is not equal to c1 by c2. Therefore, there will be no solution for this equation. All right, what about the second thing where you have a unique solution? For that, you need a1 by a2 not equal to b1 by b2, and we don't care about c1 by c2. All right, let's analyze it over here. a1 by a2 is 1 by 2 and b1 by b2 is 1 by 3, and these are not equal. Therefore, we have a unique solution for this system of equation. All right, now what about the third criteria? If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then there will be infinite number of solutions. Let's analyze it over here. We have 1 by 2, 1 by 2 and minus 100 by minus 200, which is also 1 by 2. So it's satisfying this criteria over here, and hence we have an infinite number of solutions. Hi students, in this video, let's discuss the most important algebraic identities. Let's get started. A plus b the whole square is equal to a square plus 2ab plus b square. Now how do we do this? We just multiply a plus b with a plus b. Now you can do this in 2 ways. Now one way would be you treat a plus b as one unit and you give it to a and b. So you get a plus b into a plus, because you have a plus over here, a plus b into b, right? And then you open this bracket, so this becomes a square plus ba plus ab plus b square. And that is equal to a square plus 2ab plus b square, which is what we have over here. All right. Now, another way of opening the bracket is like this: a plus b into a plus b. That's what we are trying to do, right? Now, let's give this a to here. So we have a into a, which is a square. Then I give this a over here. So that's a b, right? Now, then I have b into a. So that's plus b into a plus b into b, which is b square. So this is also one way of opening the bracket. All right. Now, let's see a few more, and then I'll tell you an interesting way with which you can initially remember these by heart, right? So that will help you memorize it. But with practice, automatically you will start remembering these identities. All right, let's proceed. The next identity is a minus b the whole square, which is equal to a square minus 2ab plus b square. All right, so over here also you can check it out by multiplying a minus b with a minus b. All right, now the next one would be a plus b the whole cube, which is equal to a cube plus b cube plus 3ab into a plus b. Now over here you can check it out by doing a plus b into a plus b into a plus b. So first you simplify this part and then you multiply that with a plus b. So you'll get this part. Now another one would be a minus b the whole cube, that's a cube minus b cube minus 3ab into a minus b. Now I'll tell you a way to remember these four identities. Now from these two identities you can get two more, a cube plus b cube and a cube minus b cube, right? Over here you have a cube plus b cube. So you take everything else to the left hand side and you will get this expression over here, that is a cube plus b cube is a plus b into a square plus b square minus ab. Remember, it's a minus over here, though you have a plus over here. All right, and over here you have a cube minus b cube. You take everything else to the left hand side and you will get a cube minus b cube is equal to a minus b into a square plus b square plus ab, which is this equation over here. All right, now let's keep these aside and I'll show you a trick to remember these. Now the trick involves the Pascal's triangle. Now first let's see how to construct the Pascal's triangle. We start with 1 and then we have 1 1, and in the edges you will always have 1. So in the third row also you have 1 and 1 in the ends, and in the middle it's the sum of these two. So 1 plus 1 is equal to 2. All right, the next row also will have 1 and 1 at the ends, and this term would be 1 plus 2, which is 3, and this term is 2 plus 1, which is 3. All right, now an important thing to remember is a plus b the whole square will have 2 plus 1, that is 3 terms in its expansion. So you can see that we have 1 2 3 terms. Similarly, a plus b the whole cube will have 3 plus 1, that is 4 terms in the expansion. So over here you can see 1 2 3 and 4. So there are 4 terms. All right, now let's proceed. Now we know that a plus b the whole square will have 3 terms in the expansion. So let's take the row in the Pascal's triangle which has 3 terms. So that's this row, right? So over here we have 3 terms, therefore it correlates with this row in the Pascal's triangle. And a plus b the whole cube or a minus b the whole cube have 4 terms, so that correlates with this row in the Pascal's triangle where we have 1 2 3 4 terms. All right, now these are nothing but the coefficients of the expansion. So let's try to find out a plus b the whole square. Now we know that it has 3 terms, right? So let's mark 3 positions. Now let's use 1 2 and 1 as the coefficients. So I have 1 over here, 2 over here and 1 over here. Now I start with a to the highest power, which is 2. So I have a square over here. In the next term, I reduce the power of a by 1 and increase the power of b by 1. So over here there is 0 power of b. So b goes from 0 to 1 and a's power goes from 2 to 1, right? So a's power goes from 2 to 1 and b's power goes from 0 to 1. So over here I have a to the power 1 and b to the power 1. Now over here again a's power goes from 1 to 0 and b's power goes from 1 to 2. So I have a to the power 0, and I don't need to write that because a to the power 0 is 1 and b to the power 2. So I have b square over here. Alright, now because I have a plus over here, I just need to fill all the places with plus, and this is the expansion of a plus b the whole square. Now let's do a minus b the whole square. The terms are the same. The only difference is that when I have a minus over here, I need to alternate between plus and minus. So I start with a plus. So I have a plus over here and a minus over here and a plus over here. So this is the expansion of a minus b the whole square, which is a square minus 2ab plus b square, which is what we have over here. Alright, now let's do a plus b the whole cube. Again, there are 4 terms involved. So let me mark 4 positions. Now let me use 1, 3, 3 and 1 as the coefficients. Alright, now the first term has the highest power of a, which is a cube. So that's a cube over here. Then I reduce the power of a by 1 and increase the power of b by 1. So over here I have a square b. Again, I reduce the power of a by 1 and increase the power of b by 1. So that's ab square. And I reduce the power of a by 1 and increase the power of b by 1. I have b cube over here. Now because I have plus over here, let's fill everywhere with plus. So this is the full form or the expansion of a plus b the whole cube. That's the same thing that we got over here. This is a cube plus b cube plus 3a square b plus 3ab square, right? Which is what we have over here. Alright, now let's do a minus b the whole cube. That would be the same thing, same expressions. Only thing is that you need to alternate between plus and minus. So plus over here, minus over here, plus over here and minus over here. Alright, now this is just to get started with, right? So it helps you think about it in a better manner. But with practice, you will easily be able to remember these identities by heart. Now from these two, we can derive these two also, right? Over here, let's do it over here. I have a cube and I have b cube, right? Let's take this to the other side. So I get a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b, right? Now let me take a plus b as a common factor out. So that's a plus b into, over here I'm left with a plus b the whole square, and over here I'm left with minus 3ab, right? Now what is the simplification of this? Let me write that over here for the purpose of space. So I have a plus b into a plus b the whole square, which is a square plus b square plus 2ab minus 3ab, right? So that gives me a plus b into a square plus b square minus ab, which is this equation over here. Similarly, a cube minus b cube will be a minus b into a square plus b square plus ab. Now if you just put your mind to it, you can easily by heart these. Now it's helpful to know this and have them ready at your fingertip. Alright, now let's see some more algebraic identities. The next important identity is a square minus b square can also be written as a minus b into a plus b. Alright, now let me relate this with geometry. Now over here I have a square of side a and I have another square of side b inside this square. Now you can refer the section in geometry. The area of a square of side a is a square. So this whole part would be a square and this part would be b square because this square is of side b. Now a square minus b square then would be this shaded region, right? Alright, now let's see how we can relate this with geometry. Now I join these 2 points over here. Now I have a trapezium over here, which is just a special type of shape which you can refer more about in the geometry section. Now I have this part over here. I rotate it and I place it like this over here. Alright, now the initial area which we shaded is nothing but this area itself because we just realigned it, right? Now you can see that this much over here is a because we said that this square is of side a and this is b. So therefore this much over here will be equal to a minus b, right? Now we know that this much is equal to a because that's part of this square and this over here is equal to b, right? Alright, so because we took it from here, right? Remember it was placed like this over here and this is equal to b. That's what we have over here now. So this is a and this is B. So this side over here will be A plus B. So we are getting a rectangle of length A plus B and width A minus B, and we know that the area of a rectangle is length into breadth. You can see that in the section where we deal with rectangles in geometry. Now over here we get that this shaded area is equal to A plus B into A minus B. So geometrically we have seen that A square minus B square is equal to A plus B into A minus B. Now again, let me repeat, this is just to get you started with. Once you use this a few times, you will easily be able to remember these identities. Now a few more important identities, let me list them over here. So x plus A into x plus B is equal to x square plus A plus B into x plus AB. Now we will use this where we deal with quadratic equations. You can see this in the higher concept algebra section where we deal with quadratic equations. We'll be using this. Now two more over here, A plus B plus C the whole square. Let's try to remember it using the pattern. That's A square plus B square plus C square plus 2AB, and instead of A you put B, you get B over here. Instead of B you put C, so you get BC over here. And again, instead of B you put C, and instead of C you put A to get 2CA. So what we're doing is that's like cyclic nature. A, you have A over here, you have B over here, and C over here. So over here we have AB, then over here wherever A is you will put B. So over here we had A, so over here we get B, and wherever we had B we put C. So over here we had B, we get C over here. So over here we have 2BC. Similarly, wherever we have C we put A. So 2BC becomes 2CA. So A plus B plus C the whole square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Alright, and what about A cube plus B cube plus C cube minus 3ABC? That's equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Now it will be helpful in solving questions if you know these identities.